Okay, we're continuing with page 19 and we're up to the fourth row, multiplying fractions. Multiplying is the easiest. The rule is to multiply across the numerators. 2 times 3 is 6. And multiplying the denominators, 3 times 4 is 12, and that simplifies to a half. Now, to avoid needing that extra step of simplifying, it would be helpful to learn how to simplify before we multiply, and it makes the multiplying easier as well. So what we do is we look for numerators or denominators for common factors between numerators and denominators. For example, I can see between the 2 and the 4 there's a common factor of 2. 2's into 2 go once, 2's into 4 go twice. And of course between 3 and 3, 3's into 3 go once, 3's into 3 go once. And now when you do the multiplying, 1 times 1 is 1, and 1 times 2 is 2. So I'm left with a half. If we try the second one, let's do some simplifying first. You can see there's a common factor of 4. 4's into 4 go once, 4's into 8 go twice. And now we can multiply. 7 times 1 is 7, and 2 times 5 is 10. Okay, on to the third one. Now before we multiply, we'll change these to improper fractions, top heavy. So if we write this one in quarters, 2 whole pizzas would be 8 quarters, plus another 3 is 11. Or you might remember to do 2 4s are 8, plus 3 is 11 quarters altogether. So changing the second one into thirds. There's 3 thirds in 1 whole pizza, plus another 2 thirds will make 5. 3 times 1 is 3, plus 2 is 5 thirds. Check for any simplifying, no common factors. So 11 times 5 is 55, 4 times 3 is 12. And we could change that to a mixed number if we wanted to. Right, moving on to the next one. There's a couple of ways we could do this. Of course, 5 times 3 is 15, 5 times a half. 5 halves would be another 2 and a half added on to the 15, so 17 and a half doing it in our head. But using the method we've just been using, 5 can be written as 5 over 1. Any whole number can be written as a fraction by bringing over 1. Changing this, 3 and a half, how many halves altogether? 3 2's are 6, plus 1 is 7. Just check for any simplifying before we multiply. No. 5 times 7 is 35. 1 times 2 is 2. And we could change that to 17 and a half if you want to. Okay, moving on to division. Now the rule for dividing, you might remember. Change the divided by to a times. Dividing by fraction is the same as multiplying by its reciprocal. We proved that last year. Reciprocal means turn it upside down. Now just check for any simplifying. 4's into that go once, 4's into that go twice. 5 times 1 is 5, and 2 times 1 is 2. We could change that again too. Another example, change the divided by to a times and find the reciprocal of the second fraction. Look for any simplifying between the numerators and denominators. I don't think you can with this one. So multiplying across the top, 3 times 9 is 27, and 4 times 8 is 32. Okay, this one looks a bit more complicated, so what we'll do is we'll change the fractions into top heavy, improper. 3 3's are 9, plus 1 is 10 thirds, divided by 4 times 1 is 4, plus 1 is 5, 5 quarters altogether. Right, we're going to struggle for room to fit this in. 10 over 3, change the divide to a times, find the reciprocal of the second fraction. Now any simplifying will help us with space. Yep, 5's into that go once, Both into that go twice. 2 times 4 is 8. 3 times 1 is 3. 2 and a third. 2 and 2/3. Okay, we'll try this one. We can write 8 as 8 over 1 divided by, and we'll change this to an improper fraction. 2 times 4 is 8 plus 1 is 9. And now we'll do the division. Change the divide to a times, find the reciprocal of the second fraction. Look for any simplifying. 4 times 8 is 32 and 9 times 1 is 9. Okay, this is a quarter squared, so let's remind ourselves what squaring means. Squaring means times it by itself. 1 times 1 is 1. 4 times 4 is 16. 1 over 16. Okay, negative 2/3 times negative 2/3. Of course, we're squaring, so we have to times the whole thing by itself. 2 negatives make a positive. 2 times 2 is 4, and 3 times 3 is 9. Now, square rooting a quarter, you can use a calculator, but for this one I'll just show you a little trick. When you square root a fraction like that, you prove later on that you can actually get the same answer as square rooting the top line and square rooting the bottom line, which is nice because both those numbers are perfect squares, they have square roots, so the answer will be 1 over 2. Now this one is going to need a calculator. Just make sure you can use the fraction button on your calculator. You may need to use brackets around the 7/12ths, and on the calculator we'll just leave it as the decimal 0.7637 and so on. Right, there's one more row to go on this page, but you need to have a go at using the calculator for it and using brackets around the fractions.